next speaker. Thanks very much for this fantastic overview. And I would like to correct myself. My Jasper reminded me that I'm rather of an amateur when it comes to Zoom hosting compared to our IcePack colleagues. So please post your questions to the Q&A function, not the chat function, as I said before. And we would encourage you also to mention your name, not send anonymous questions. I mean, of course, if you have a reason not to reveal your name, feel free to, but we would encourage you to do otherwise. And without further ado, I would like to introduce our next speaker, Dr. Jakob Tarp from Aarhus University, until recently with NIH, the Norwegian Institute for Sport. Jakob is doing us a big favor today because he's covering for Ulf Ekelund. So you may have noticed that Ulf Ekelund was in the program initially, but Ulf unfortunately had to withdraw his participation because of some eye surgery, as it happens. So Jakob, thank you again and welcome to our symposium.
Thank you very much, Manos. Do you see my slides?
Yes, I can see your notes slides, your notes version, not the...
Is this better? Yeah.
Yeah, that's the correct...
Okay, thank you very much for the introduction and thanks for letting me speak here in place of Ulf. And I will be talking about some specific examples of device-based data. And after this kind of big picture talks so far, we'll be looking at some of the real-life examples of what have been done and how their different approaches influence the data presentation and may also influence the results. So there's no doubt that the advent of devices has improved measurement of physical activity by substantially reducing the random error and the biases associated with the self-report. But devices are by no means a true objective measurement in terms of they don't represent a ground truth of physical activity without any uncertainties. For example, there are a range of different post-processing decisions that impact the absolute levels of physical activity recorded by these devices. And that may or may not impact the dose-response relationships with health outcomes. So, for example, I highlighted here two studies, the British Regional Heart Study and the Women's Health Study, published in the same year, both analyzing moderate to vigorous physical activity against all-cause mortality, splitting their sample into quartiles and using the least active F as the reference. And what we can see here is there is just a substantial difference in the magnitude of the associations and also the dose response patterns. And comparing the definitions of moderate to vigorous physical activity suggests that this may have something to do with these post-processing decisions, but it could also be due to different samples or different covariance adjustments. So it leaves questions open for interpretation. And as we've heard here, a key mission of the physical activity community is still to understand the dose-response relationships for an ever-expanding range of physical activity and sedentary behavior exposures, with also an ever-expanding range of health outcomes. Now, not only mortality and morbidity, but also mental health and physical function. And this just calls for harmonization to kind of rule out these post-processing influences. And kind of to go back to the start, the very first example of an attempt to harmonize physical activity data is the ICAT study, the International Children's Accelerometry Database. It was created almost 15 years ago, between 2008 and 2010. It went live in 2011 and I guess really kicked the door in for physical activity research in 2013 by publishing this paper in JAMA by Ulf and a lot of great colleagues. And The novel feature of the ICAT was not really that it showed how total physical activity or moderate to vigorous physical activity was associated with cardiometabolic risk factors here in table 5, and that the association between sedentary time and these outcomes in kids were maybe less convincing. But the real strong point of this analysis was that the sample size was large enough to create these 9 combinations of physical activity and sedentary time to show how these factors collectively influence, in this instance, waist circumference in kids. So this was a truly novel innovation and really kind of set the stage for these harmonization projects. And what was so fascinating about ICAT was that they invited contributors to send all their accelerometer files, all the individual participant data, along with a few covariates for some attempts at harmonization other than physical activity. And then they took all the physical activity files and then they reprocessed them centrally in one computer using the same cut points, non-wear, all these post-processing decisions that we know influence absolute measurements of physical activity. And they did that to create one common data set that could then be reanalyzed again and again, answering different questions, and have done so, leading to very, very many publications. But of course, to achieve this requires extensive resources and commitment to true long-term outcomes. Remember, this started in 2008 and is still ongoing. And also, a lot has happened with ethical and confidentiality issues since 2008. And it's quite unlikely that something like ICAT, pooling all the data centrally, would be possible today. And that is even without trying to include any mortality or disease data. So a more feasible approach to kind of harmonize data from different studies, if you don't have this massive amount of resources at your disposal, could be something like the what we call the Adult Accelerometer Consortium, which was a project including 8 cohorts with device-measured physical activity in relation to mortality, published in BMJ in 2019. And in contrast to ICAT, which was based on collecting all the data in one computer, the Accelerometer Consortium took a more feasible, pragmatic approach, where harmonization was done at the local level. So all the participating cohorts reprocessed their accelerometry data according to a standard protocol with common decisions on cut points, epochs, non-wear, valid day criteria to kind of rule out any heterogeneity due to these different decisions. And also contributors performed the analysis locally based on study-specific covariates and also study-specific quartiles of physical activity, and then shared their summary estimates with the writing group for pooling in a conventional meta-analysis. So the difference here is really that the processing of the accelerometer data is standardized compared to a conventional meta-analysis of observational studies. And this is feasible because there are no ethical or legal considerations on summary data. And of course, a drawback is that it requires additional commitment from partners as the analyses are performed locally, and as the analysis may develop and call for follow-up questions. This will have partners go back to the data and do the analysis again, which would not be necessary in something like ICAT. And because this work was at the time, now UK Biobank has kind of taken over as the largest collection of device data, This study really made a big impact in terms of showing how any kind of physical activity, total physical activity, light, low light, high light, moderate to vigorous, and sedentary, was associated with mortality, and the results here in table 2 are shown for the pooled quartiles. So this study came out at a really nice time for the WHO 2020 guidelines and really helped to emphasize the message, sit less, move more. And I think what was really fascinating is that this was performed without any financial support whatsoever. So this was just people willing to do some really interesting work. And another example, another very recent example, is the Steps for Health collaborative. They reviewed the literature for studies on steps and mortality data to try to dig into this dose-response relationship for this measure of physical activity. And they were able to include a total of 15 cohort studies based on a range of different step devices. And again, based on local processing of accelerometry data, local analysis, and sharing summary estimates with the writing group, and according to a common protocol. And because this initiative now included a total of 15 studies, they were able to do some subgroup analysis by age and sex, and I've highlighted them here in the box for age, showing some potential heterogeneity in the dose-response relationship between steps and mortality by age. So this is clearly way more feasible to just have people do their analysis like they usually do and then pool it in a meta-analysis compared with something like ICAT. So what are the caveats of doing this type of study level meta-analysis? And there are several caveats, but I've kind of highlighted 3 that I think are important to discuss here. And the first one is that determining the dose-response relationship, which is kind of really what we want to do, is challenging, because going back to the quartiles of the Adult Accelerometer Consortium, I showed you before the pooled effect sizes, the hazard ratios, but this is a forest plot showing the individual study results going into these pooled hazard ratios. And while we can see the dose-response relationship, this is for moderate to vigorous physical activity, we can see that there is a substantial variation in the absolute level of physical activity in these quartiles. So, for example, the median physical activity level in the second quartile was 6 minutes per day, but the range across cohorts was 1 to 24 minutes. And in the most active quartile, the median moderate to vigorous physical activity level was 38 minutes per day, but also again with a substantial range from 20 to 63 minutes across cohorts. And we can even see that some of the what would be quartile 4 in one study could be quartile 3 in another study. And of course that has very large implications for the quantitative guidelines that can be derived from these data. So to kind of overcome this variation in absolute levels across the studies, we try to pool all the data into a continuous dose response analysis, and this is shown here in the figure. This is based on the same data, so it's study-specific quartiles and median physical activity level, and then the hazard ratios and the confidence intervals to kind of decide how much weight is given to each study. And while this figure definitely looks very nice, showing a very strong inverse dose-response relationship by doing any level of moderate to vigorous physical activity, and then with a lot of uncertainty at higher levels of activity, the underlying data, I think, maybe calls for more caution in how certain we can be that this is actually the dose-response relationship. And These dots represent the individual data points, and the size are proportional to the amount of information they contribute. And what I kind of think is interesting is that the resulting line is kind of going in between two dots of hazard ratios. So the resulting line is really somewhere where there is really none of the studies really had these estimates. And we can really see that at the upper level of physical activity, there is a clear lack of information, and I think clearly we need more studies to inform these dose response patterns, but this is a start. So subgroup analysis have limited power, and while I alluded to potential age heterogeneity in the steps collaboration, this is again a pooled continuous dose response meta-analysis. And while we can see that it looks like there is some heterogeneity, we can also see that there is an area where the confidence intervals and the point estimates really do overlap. And because it was based on summary level data, there was no test of interaction. So how certain can we be that these differences are real? And there are some examples in the literature where meta-analysis of summary level data can lead to what is called ecological bias, a type of confounding, where this is a meta-analysis of hypertension treatment, where the blue boxes represent the individual studies, and we can see that the lines in each individual studies are really horizontal, which here suggests that there are no real gender differences in the treatment effect. But when we pool all the data, we can see that there is a correlation between lower treatment effect with a higher proportion of males in the study, which would suggest heterogeneity. But when this data was reanalyzed based on individual participant data, as in ICAT, there was no such gender heterogeneity in effects. So this would be some kind of ecological bias. Finally, analytical flexibility is low. So for instance, if the results of a harmonized analysis based on summary data shows maybe we need to dig more into this, then it would require all the collaborators to go back to the data and re-perform their analysis, which would be very time consuming. So it's less flexible also in terms of reviewer comments or even new ideas that may be generated during the process. And this is an example of a harmonized data set based on individual level data, where they really looked at mediation and moderation to try to get into the mechanisms, and something like that would be quite difficult based on summary level data. So because of these limitations, we wanted to revisit the dose response pattern between physical activity and sedentary time based on individual level data. So Edvard Sargelf, a PhD student from the University of Tromsø, has led a pooling project of 4 cohorts with 12,000 participants from Norway, Sweden, and the US. And because we are now pooling all the data, we have enough statistical power to detect a significant interaction between physical activity and sedentary time, which I think is really interesting. And this is some new data that's unpublished. It's currently in submission, and I want to share it with you here today because I think it's really interesting and demonstrates what we can do with individual level data. And what this figure shows is that in those participants in blue who are meeting the physical activity guidelines, so 150 minutes of moderate to rigorous physical activity per week, there is no association between sedentary time and mortality at all, while there is a very strong association with high levels of sedentary time and mortality in those who are not meeting the guidelines, the red line. And this is interesting because this level of physical activity is much slower than what is currently communicated in the physical activity guidelines by the WHO, that high levels of sedentary time calls for physical activity levels above the recommendations to eliminate this excess risk. So we look forward to sharing these results and discuss their potential implications. So the question is, of course, then, is it possible to combine the benefits of individual participant data with the ethical and legal requirements of today? And it is possible, and ProPASS, I guess, is really championing this approach in the physical activity space. But there was a paper published 1 or 2 years ago by Sebastian Chastain, who also demonstrated this approach, that there is new software available to secure an environment for local storage of data with the additional analytical options in the individual participant data meta-analysis. And this is based on what is called a federated analysis. And they managed to pool 6 studies to apply a compositional data analysis. And I think important insights will come from this approach in the future. But I think an important thing to highlight is that comparing the 6 studies on moderate to vigorous physical activity here in table 2 reveals that there are some substantial differences in the physical activity levels across the cohorts. And you can see that the UK Biobank and the Whitehall 2 cohorts have much higher levels of physical activity than the remaining cohorts. And that is because they are based on wrist-worn accelerometry, indicating that these data are probably fundamentally not comparable at all. And they ended up analyzing this data separately from the hip-worn accelerometry. And I think I will end shortly, Manas, don't worry. This leads to important considerations about what is it that needs to be harmonized, because harmonization of cut points and non-wear and wear time may be trivial if the data collected is fundamentally not comparable, such as wrist and hip-worn accelerometry. And there is some work in this space based on bridging equations to convert different physical activity outputs into common metrics. And I think this is a very interesting field that we need to work on, because if we want to provide quantitative guidelines, we need to be able to include all of the evidence and not have different quantitative guidelines depending on how we measured physical activity by the wrist or on the thigh or on the hip. So I think this will be important to consider in the future. So I'm ending with this slide, just summing up the main differences between the ICAT approach, the individual participant dataset, the accelerometer consortium steps approach based on summary level data, and then the federated real-time access platform demonstrated by Sebastian Chastain, and also which ProPASS is working on developing. So thank you very much, Manas.
Thank you, Jakob. This talk provided a huge amount of food for thought, especially on the methodological front.